Alright guys, today we're going to talk about measures of central tendency, but before we do that, we're going to do a nice little warm-up here. I have 3 questions over here on the left and 4 over here on the right. Let's start on the left where it says round 803.119 to the nearest tenth. Now just a reminder, the nearest tenth is only one number after the decimal place. So to determine what to round it to, we need to look at the number that comes after that. So if I want to round it to this dude right here, I want to look at this guy right here. Now, if that guy is greater than or equal to 5, we round the number up to the next one. If that guy is less than 5, then we leave it where it's at. So, since this number right here, this second one, is less than 5, we're going to leave this at 1. So, rounded to the nearest tenth, this is going to be 803.1. The next one says round 23.0368 to the nearest thousandth. Now, if I have a number, so let's go 1.23456. First number after is the nearest tenth. Then we have hundredth, thousandth, 10,000th, etc. So, to round to the nearest thousandth, that is going to be the third number after the decimal place. So in this case, 0.036. Now, if I want to round to that number, again, I need to look at the number right after it. If it is greater than or equal to 5, we round up. If it is less than 5, we leave it the same. So since 8 is greater than or equal to 5, this 6 is going to go to a 7. So this is going to be 23.037. Alright, now we have round 8.7495 to the nearest hundredth. Hundredth is the second number after the decimal point. So here would be this 4. So again, we need to look at the number that comes right after it. Look at this 9. And since it's larger than 5, we're going to round this up to 8.75. Alright, that's just some basic knowledge that you are going to need this year. You need to know how to round and what tenth, thousandth, hundredth, all of that good stuff means. Now we're going to come over here and do some basic conversions, nothing you guys haven't seen before. So 1 foot is how many inches? Hopefully we know that there are 12 inches in a foot. 1 yard is how many feet? So a yardstick has 3 feet in it. Now it wants to know 1 yard is how many inches. So if there are 12 inches in a foot and there are 3 feet in a yard, we're going to take 3 times 12 and that'll give us 36 inches in a yard. And then this last one you may or may not know. It is very helpful for us this year. 1 mile is 5,280 feet. Alright, now we're going to move on and we're going to talk about measures of central tendency. Measures of central tendency is composed of 3 different things: mean, median, and mode. And yes, I know that you guys have done this before, so this should be a pretty quick lesson. The mean, just a quick refresher, is the sum of the data values divided by the total number of data values in the set. The median is like the middle, and the mode is what occurs most often. There can be more than one mode, or there could be no modes. So on number 1, it says the table below shows the number of hits Marcus had versus each opponent. Find the measures of central tendency. So we want to find the mean, median, and mode for all of the hits that he had. Now, we don't just want to put the numbers down and call it good. We need to make sure we keep this nice and neat and organized so I can look and know exactly which one is which. So we're going to start with the mean. Now you can write the word mean if you want. You can say this is the mean, and you can show it that way, or just so you know, you will be seeing it this way a lot on my answer keys, and in the future there's a shorthand for mean, and it just looks like an X with a bar on top of it. That is like a shortcut for mean, and we want to find the mean of all of these numbers. So what we want to do is we want to add them together. So let's get out our calculator here, and we're going to say 3 plus 6 plus 5 plus 2 plus 3 plus 7, and we're going to get 26. So the sum of these numbers is 26. And then we want to divide that by how many total data values we have. So we have 1, 2, 3, 4, 5, 6. We want to divide that 26 by 6. And if I do that in my calculator, we're going to get 4.3 repeating. Now, what that means is we're finding the average number of hits that he's played against each team. So I don't just want to say 4.3 repeating, we're going to round that to the nearest tenth. So when I round, I need to show that it's an approximate answer. It's not exact, so I'm going to have my approximate answer right there. And to round to the nearest tenth, remember 4.3 repeating is like 4.33333. So I just want to round to that first digit. I look at the second, it's less than 5, so we're going to leave it at 4.3. So it's approximately 4.3, and then I need to finish it up with a label so I know what we're talking about. We are talking about the number of hits, so he has approximately 4.3 hits per game. Next thing we're going to talk about is the median, and the median is the middle value of this data. So to find the median, it's very important that you have your numbers in numerical order. You can't just choose the number in the middle of how they listed it. You've got to make sure that it is in numerical order. So we need to take a minute and rearrange these numbers to go in order from smallest to largest. So for me, I'm going to start by looking for the smallest number, which is 2, and then I'm going to cross it off. And then the next smallest number is 3, 5, 6, 7. So now that I have all of my numbers listed out in numerical order, we're going to talk about how to find the median. Now, I understand that you guys have found the median in the past. It's just the number in the middle. But today we're going to talk about an easier way to identify it that requires a little bit less work. So to find the median, first you need to determine how many terms you have. So for us, we had 1, 2, 3, 4, 5, 6 terms. And that is an even number of data terms. So since I have an even number of terms, the median will actually be the mean of the two middle values of the set when listed in numerical order. Because I understand that in the past you guys have probably learned it as you go through and you mark off the first one and the last one and the second one and the second to last one, and then you're left with whatever's in the middle and you find what's in the middle of those two, which is fine and dandy when you're dealing with maybe anywhere from 5 to 10 values. But if you're given a list of 100 values or a list of 50 values even, you don't want to go through and mark off all of those numbers. That's a lot of work. So since we know that there is an even number of data terms, we need to find the two middle values and then find the average of them. So here's what that means. We need to take the middle two terms, add them together, and divide them by 2. So since I have an even number of terms, we have 6 terms, we're going to divide that by 2, so 6 divided by 2 is 3. So I'm going to count 1, 2, 3. This is my third term, and that means this term and this term, these two dudes right here, are my middle terms. I want to add them together and divide by 2. So 3 plus 5 is 8. Divide that by 2, and I get 4. And don't forget your label. Now I understand at this point you're probably a little bit confused. Like, how is that easier, Mrs. Getz? That just sounds weird. It does get easier. It's mainly there for when you have a lot of terms. So just keep that in mind. And finally, the last thing that we need to find is the mode. And the mode is what occurs most often. So if you'll look, we have 2, 3, 3, 5, 6, 7. 3 is what occurs more than once. This occurs one time. 5 occurs one time, 6 and 7 both occur one time, so 3 is what occurs the most often, so the mode is 3 hits. And just a reminder, you can have more than one mode. You can sometimes have no mode, and that's okay. Alright, moving on to number 2, it says, 2 basketball teams face off in a heated game. The heights for each team's starting lineup is listed in the chart below. find the mean height for each team. So they don't want us to find the mean, median, and mode. They just want the mean. So we will need to find the mean for the hoopsters and the mean for the dribblers. So to find the mean, we need to add all of the heights up and divide by how many players there are. So starting with the hoopsters, we have a team player who is 5'6", 5'6", 6'6", and 7 foot. So we need to add all of those together, but be careful, because when you have a player that is 5 foot 6 inches, we can't put that into our calculator as 5.6, because 6 inches is not 0.6 feet. In fact, I hope you guys remember from up top, 1 foot has 12 inches. So if this player is 5 foot 6 inches, if I take 6 and divide it by the total number of inches in a foot, that's going to give me a half a foot. So 5 foot 6 inches is actually 5.5 feet. So these two values are really 5.5. Now we can add all those together and divide by how many. So I'm going to bring this over here. We have 5.5 plus 5.5 plus 6 plus 6 plus 7. And that gives me a total of 30 feet. But I still need to divide by how many players we have, and there are 5 players. So 30 divided by 5 is a mean, or an average, of 6 feet. So they have an average height on their team of 6 feet. Now the dribblers, all 5 players are 6 feet. So let's go ahead and find the mean of that. We can add them all together. 6 plus 6 plus 6 plus 6 plus 6. Well, 6 plus 6 is 12, plus 6 is 18, plus 6 is 24, plus 6 is 30. Divide by how many players there are, and we get an average height of 6 feet. So, even though we have 2 very different data sets, they come out with the same average, which is okay. However, if you are looking at the average or the mean to describe the data sets, it can give you a little bit of a false sense of what's going on. So that's where a new measure of spread comes in called range. Range helps us see what the difference is in the data set between the maximum and minimum values. So let's find the range of each team's height. So if I wanted to start with the hoopsters, to find the range, I need to take the maximum value, which is my biggest number, and subtract the minimum value, which is my smallest number. So in the hoopsters, the maximum height is 7 feet, and we want to subtract the minimum height, which was 5.5 feet. So we can use your calculators to do that. 7 minus 5.5 gives me a range of 1.5 feet. Now we can do the same thing for the dribblers. We want to take the maximum height, which is 6, and subtract the minimum height, which is 6, and we get a range of 0 feet. So, mean, median, mode, and range. Those are all there to help us describe a set of data and to help us get an idea of what's going on. So on the back side, we're going to talk about something now called box and whisker plots. And to make a box and whisker plot, you need to find something called the 5-number summary. And the 5-number summary consists of 5 different numbers, obviously. The first number is the minimum, and then we're going to have something called the first quartile, then the median, the third quartile, and then the maximum. Now, 3 of those words, hopefully you already understand what they mean, but there are 2 words that are a little bit new to us. So we're going to go down here to number 5, and we're going to walk through how to find these. So it says, create a 5-number summary for the ages of teachers in the math department at Big High School. So they have given us a bunch of different ages for math teachers at Big High School. The first thing we want to do is we want to make sure that these are in numerical order. So did I start with the smallest number and progress to the largest number? So let's double check. 25, 31, 36, 39, 40, 41, 44, 45, 49, 50, 54. They are in numerical order, which is very good. Now that they're in numerical order, we can start to find the 5-number summary. So we're going to start with the 3 numbers that we definitely know how to find. The easiest one to find is definitely the minimum. Since it's in numerical order, it's just the first number. It's the smallest number that we have, which is 25. So here's what we need to do. We need to label that as the minimum. And you can abbreviate MIN, that's totally fine. The next easiest number to find is the maximum, right? The minimum is the smallest one, the maximum is the biggest one. Since it's in numerical order, it's just going to be this last one over here. So I'm going to label it as the maximum, and you can abbreviate as MAX. The next easiest number that there is to find is the median. Again, it needs to be in numerical order, so it's good that it is, and it is going to be the middle value. Now, we're going to use the method that we learned on the front page. So first we need to determine how many terms we have. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 terms. Now, according to the first page, 11 is an odd number of data terms. And when there is an odd number of data terms, you take that number, so we said we have 11 terms, we're going to divide that by 2, and we get 5.5. Then we're just going to round up. 5.5 rounded up is 6. That means the 6th term of our data set is the median. So if we come back here, I can start 1, 2, 3, 4, 5, 6. This guy right here, 41, is the median value of our data. Now, the last thing we have to find is the first quartile and the third quartile. Now, we need to find this by working with the median again. So all that it means when you're finding the first quartile, it is the median of the terms to the left of the sets of the true median. So this is our true median. What that means is we're going to look at all the numbers that come to the left of the median. Notice I am not including the median in that. So here's what I want you guys to do. I want you to take your hand and I want you to cover up everything from the median to the right. So I'm covering up the median all the way to the max. And I'm left with 1, 2, 3, 4, 5 terms. To find the first quartile, all you need to do is find the median of these 5 terms. So 5 is an odd number. Divide that by 2. We get 2.5. Round that up, and that's going to give us 3. So the third term is our first quartile. So I can go 1, 2, 3. This guy right here is going to be our first quartile. And we're going to label that as Q sub 1. So it's like a capital Q, and then down in the lower right-hand corner, we're going to draw a smaller 1. Okay, so the first quartile is the median of the numbers that come to the left of the median. Now, to find the third quartile, it's the same thing, but instead of the numbers to the left of the median, we're now going to find the median of the numbers to the right of the median. Again, do not include the median in this. We never, ever include the median. So take your hand, and we're going to cover up everything from the median to the left. And that leaves these 5 numbers here. So again, we want to find the median of those 5 numbers, 1, 2, 3, third term right here. And we're going to label this as the third quartile. So it's going to be a Q, just like the first quartile, but instead of a 1, it's going to be a 3. So at this point, we have our 5-number summary. The minimum, the first quartile, the median, the third quartile, and the maximum. And what this does is it takes our data, it takes our values, and it splits it into 4 equal sections. It's saying this is an even distribution of the first quartile, the second quartile, third quartile, and fourth quartile. So now what we can do is we can take this data, this information right here, and we can use it to create a new kind of graph called a box and whisker plot. So number 6 says find the IQR, which stands for interquartile range, of the data above. Then determine if there are any outliers. Make a box and whisker plot with the data. So the first thing we need to do, just like with all graphs, is we need to make sure that we are working with the right set of data, and we need to make sure that we label what we're working with. So we need to start with 25 and go all the way up to 54, and let's see how many tick marks we have here. We have 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 24 tick marks. So 54 minus 25, I need to, I have a range, I have a spread of 29, and I only have 24 tick marks. So I can't count by ones, but I can definitely count by twos. So we don't want to start with the smallest number, because we don't want everything to be squished on this end over here. We want to make sure it's nice and spread even. So I'm going to maybe start a little before it at 20 and count by twos on this axis. And then if you'll notice, I labeled it with what we're working with. This represents the age of the teachers that we're working with in years. So go ahead and pause the video and you guys can label your axis. Now we need to find the interquartile range and outliers. So I have a box here with the nice formulas that you're going to need to find this information. We're going to start with the interquartile range. The interquartile range, which is often abbreviated as IQR, is found by taking Q sub 3, which remember was our third quartile, and subtracting Q sub 1, which is our first quartile. So Q sub 3, and we're going to come over here, make sure you label what you're working with. So you're saying we're going to find the IQR, the interquartile range, right here. And it's going to be our third quartile, which was 49, minus our first quartile, which is 36. Now 49 minus 36, if you need your calculator you can, but hopefully you know what that is. That is 13. So that means our interquartile range is 13. Now we need to determine something called an outlier. An outlier is a term or terms that don't seem to fit the data set. So for example, let's say I had the numbers 1, 2, 3, and 100. These three terms are all very close. They're very small. And then this one is huge. It just doesn't seem to fit with the numbers that we already have. So this would be something called a high outlier because it's way bigger than the others. Now, what if I had the numbers 100, 101, 102, and 5? These three numbers all seem to be close together, and then this number seems way lower than the rest of them. So this would be a low outlier. It's just numbers that don't fit with the data. Now, to find the outliers, it's not a guessing game. It's not something that you can look and sometimes obviously see. There's a mathematical value to find it. So let's start with finding if there's any low outliers. To determine if there's any low outliers, we need to take our first quartile and subtract 1.5 times my interquartile range. So my first quartile is 36. We do need to show this work. And we're going to subtract 1.5 times my interquartile range, which we said was 13. Now, I'm totally okay with you putting this whole thing in your calculator, so let's go ahead and get that calculator out. And we can type that in. 36 minus 1.5 times 13, and we get 16.5. So that means if there are any numbers lower than 16.5, that would be a low outlier. So if we look at our number set, our lowest number is 25, and that is not lower than 16.5. So as of this moment, there are no low outliers. Now the high outliers is very, very similar to finding the low outliers, but instead of the first quartile, we're going to use the third quartile. And instead of subtracting, we're going to add. So the third quartile is 49 plus 1.5 times my interquartile range, which is 13. So we can put that whole thing in our calculator again. So 49 plus 1.5 times 13, and we get a value of 68.5. So, since this is the high outliers, if we have any numbers larger than 68.5, that would be deemed a high outlier. Well, our largest number is 54, so we do not have any high outliers. So since we don't have any high outliers and we don't have any low outliers, that means we have no outliers at all. So what I want you guys to do when you find that out, just below it, write no outliers. That helps me see that you did the work and you thought through it and you have nothing to worry about. Now, the next thing we're going to do is we're going to take all of this data and we're going to create a box and whiskers plot. Now, to create the box and whiskers plot, the main numbers you need to worry about are those 5 numbers for the 5-number summary. We are going to take each one of these 5 numbers and we are going to plot them above the number line, not on it, above it. That's very important. So let's go ahead and start by plotting 25. So what we're going to do is we are going to find 25 on the number line. Well, we counted by 2, so this is 22, or 20, 22, 24, 26. So 25 is going to be halfway between 24 and 26. And I'm going to go above the line and put a dot there. Then, just like we did with the graphs in section 1.3, we need to label what that point is. So since that point is 25, I'm going to come above it, leave some space, and put 25. Okay, then we're going to do the same thing for the next point, which is 36. So I'm going to find 36 on my number line, come above it, and you want to be in line with the number or the point that you already plotted. We don't want to come way up here. We want to make sure it's in line or as close to it as possible. We'll put a point, and then we can label it 36. Okay? And then same thing for 41. So halfway between 40 and 42 is 41. Come above it, put a point, label it. Then 49. Label it. And finally 54. And label it. So when you're done, it should look like this. Now what we're going to do is we're going to take our straight edge and we're going to start to connect these to create a box and whisker plot. So starting with the middle 3 terms, we're going to ignore the minimum and the maximum at this point. I would like you to take your straight edge, and on these middle 3 points, you're going to draw a vertical line, and they all need to be about the same length, straight through it. When you're done, it should look like this. Now, what you have done is you've started to create the box part of your box and whiskers. Next, what we need to do is finish creating the box. So take your straight edge and we're going to connect these 3 lines straight across and these 3 lines straight across and create a box. And then finally, we're going to create the whiskers. So use your straight edge to connect these maximum and minimum values to your box, like so. So the box and whiskers does a really good job of showing you this is all the data set, but there is the same number of data values in this section as there are in this. So the reason that we call them quartiles, like if you think there are 4 quarters in a dollar, so quartiles, there's 4 quartiles in a box and whisker. So like the first quartile would be from here to here, then we have one from here to here, here to here, here to here. It splits our data value into 1, 2, 3, 4 quartiles, 4 equal data sets. Now there is the same number of data values in the first quartile as are in the fourth quartile. There's the same number in all 4 of them. The reason that we do this is it helps us see the spread, the range. So even though we have the same number of data values in the first quartile and the fourth quartile, the values in the first quartile are a little more spread apart than the values in the fourth quartile. Now, the last thing we need to do before we move on is we need to come up with a good title for my box and whisker plot. Now, the title, like I said, 9 times out of 10, they just give it to you in the problem. So it said on number 5, the data value that we are working with, the ages of teachers in the math department at Big High School. So that's a long title, but that's okay. It's very descriptive. So just make sure we put that up top. Everything is capitalized like it should be. And there we have our first box and whiskers set. Now, on number 7, they already gave us a box and whiskers plot. It says, find the 5-number summary of the points Rick had in each of his basketball games. Then, determine if there are any outliers. Use the 5-number summary to make a box and whisker plot. So what they did is they already made the box and whisker plot. We have to identify the minimum, first quartile, median, third quartile, maximum, interquartile range, low, high, outliers. So we're going to do a little bit of math here. Let's first of all make sure these numbers are in numerical order. And they definitely are. So now we can identify our 5-number summary. So remember the easiest value points to find in your 5-number summary starts with the minimum because it's the very first one. Then we can find the maximum because it's the very last one. Now the median was the one in the middle, so we need to determine how many values we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now 10 is an even number, so if I divide that by 2, I get 5. Since I get a nice number when I divide that by 2, I need to add the 5th and 6th terms to the next one, and then divide by 2 to get the median. So 1, 2, 3, 4, 5. I need to add 16 plus 18 and divide it by 2. So 16 plus 18 divided by 2 gives me 17. That means 17 is our median value. But I don't see a 17 on here, so here's what we need to do. We need to draw a line in between them, and then we need to write that that's the median. And then we need to say what the median actually is numerically, so I'm going to put a 17 under it. That shows, hey, I did my work. The median is 17. Now finally, I need to find the first and third quartile. So to find the first quartile, I need to find the median of all the numbers to the left of the median. Remember, we do not include the median in that. So I'm going to take my hand and I'm going to cover up the median all the way to the right. And then I have 1, 2, 3, 4, 5. So the term in the middle is 14. That's my first quartile. And we're going to do the same thing to the left. Cover up the median and all the numbers to the left of it. And I have 5 numbers over here. Find the number in the middle, and that's going to be my third quartile. So we've identified my 5-number summary here, but here's a little hint that we could have used. If you come down here, it should have already given you that. Now, we just need to make sure we fill out this table. So we said the minimum was 8, the first quartile was 14, the median was 17, the third quartile was 20, and the maximum was 30. Now, we need to identify the interquartile range, the low, and the high. So remember, the interquartile range is my third quartile subtracting my first quartile. So my third quartile is 20, my first quartile is 14, so 20 minus 14 gives me an interquartile range of 6. Now to find the low outliers, you guys have the box right above it with the formula. It's the first quartile minus 1.5 times the interquartile range. So my first quartile is 14 minus 1.5 times my interquartile range, which is 6. And we can put that whole thing into our calculator. So 14 minus 1.5 times 6, and that gives me a low outlier of 5. So if I look, none of these numbers are lower than 5. So I don't have any low outliers. So since I have a low outlier of 5 and I don't have one, I'm going to come down here below it and just put none, because that helps me to understand I don't have any outliers. Now to find the high outliers, I need to take the third quartile and add 1.5 times the interquartile range. Now what I'd like you guys to do is I'd like you to pause the video and find the high outlier on your own. Now hopefully you found that the high outlier was 29. So any number higher than 29 is an outlier. So if I go back and look at my terms, I do now have a number that's higher than 29. We have a number that's 30. So we need to circle this number. That shows us that 30 is an outlier, and we're going to come down here and write it below it. So 29 was the high outlier, and we have one, which is 30. Now I want you guys to come over and take a look at this graph. We want to see like how this information relates to this graph here. First of all, the minimum is 8, so that's the lowest point. First quartile was 14, that's the first point in the box. Median was 17, that's the second point in the box. Third quartile is 20, that's the third point in the box. Now the maximum was 30. But if you'll notice, it's not connected over here, and that's because it's an outlier. When you have an outlier, it still needs to be on the graph because it's still technically your maximum value, but since it doesn't fit in with everything, it's separated over here. That means that we're going to then take the next highest number, which is 22, and that's going to be our, quote, maximum for this set. But the maximum is still 30. It's just an outlier, so it's not connected. All right, that wraps up our section on box and whisker plots. If you have any questions, please let me know.